So we're starting today, we're just doing a little bit of quick practice at the start of class. I'm going to give you a bunch of time to actually do more individual practice and focus on your particular needs. But the big thing when looking at these is that these look very similar, right? And for a lot of us, the trouble comes in knowing, what do I do? How do I know what I'm supposed to do with it? Because we learned that out of the type of factoring. For that first problem, the one on the left, is there anything common to every single term? Like, can I divide something out of every single term? The answer there is actually a yes. But some of you were shaking your head no. But that's because when I say, can we divide something out, you're focusing just on the numbers. But it's not just the numbers, is it? Because you'll notice that we do have x's in every term. And when we pull out an x, that is factor out an x, it's actually dividing it out of every term. It's the same idea as when we pull out a number. Now in this case I can pull out x squared because I can pull 2x's out of this, I can pull 5 out of this, 6 out of this, so I can at least pull 2 out of every term. Alright, so when we pull out x squared, that gives me x to the 4th, remember I'm subtracting the exponents, plus 6x cubed plus 9. Now, you double check yourself to make sure you've actually pulled out the biggest number. Notice, between all three of these terms, there's nothing else I can divide them all by. Because there's no x in that last term, and I can't divide that first term by 3. So yes, I now know I'm totally done. The second one looks a lot like the first one, but it's a totally different way of doing it. So for that second one, the reason why I know it's different is because when I take a look at every single term, I can't divide all three of them by a number because there's not a number that goes into x squared. Similarly, I have x's in 2 of the terms, but not all 3 of the terms. So I can't divide out any x's. So what can I do? Well, what tells me is because this meets a very specific set of requirements. And it is very specific. Notice, first of all, we start with the x being squared. If this were not a 2 here, this were a 3, a 4, if there was no exponent at all, we could not do what we're about to do. It's only because it's x squared here at the start. Okay? The other thing that makes this work is the fact that there's no number in front of x squared, that is basically it's a 1x squared, and that if I divide the 6 by 2, and then square it, I get the 9. It just happens that this follows that very particular rule. Now, for now, you're only going to be seeing ones that look like this, that follow that rule. Later, I'll be giving you more rules and we'll be seeing how we can deal with the ones that aren't set up so perfectly. But for now, we can know that when you see this, that's the type of thing you're going to do. So, how do we factor it then? When I see that setup, I know I'm going to end up with x in parentheses squared. The number that is in the parentheses is that middle number divided by 2, which we already saw was 3. Now notice that's a positive 3. Keep the same color. And since it's a positive 3, it ends up being x plus 3. Now, double check it. Does 3 squared equal 9? Yes, it does. So that tells me, yes, that is indeed the correct factorization. If you aren't sure, you could always double check yourself. Now, when I say double check yourself, what that means is that if I do x plus 3 times itself, because of course that's what squaring means, I should get what I started with. And you'll notice I would. Because when I do the 3x plus 3x, that gives me the 6x. And so yes, that is the same. Because the whole idea behind factoring is we're writing it in an equivalent form. That is just a very mathy way of saying it still equals the same thing, we just made it look different. All right. So with these two, again, I made them look very similar, but the approaches we have to take are very different. And it's a matter of recognizing how we can know. First of all, for that one on the left, x squared. 16x, 64. Can I divide all three of those terms by the same thing?
Yes.
I don't see anything I can divide all three of those by. Because I could divide the first two by x, but not the last one. I could divide the last two by 16, but not the first one. Because there is no number in the first one to actually divide out. And so, because there's no number that I can divide out, and there's not an x in every term, well, I definitely can't end up with an answer that's just something outside of one set of parentheses. Instead, that tells me that my answer is going to be formatted
Is it x minus h squared?
like this. And so, we got the x there. To find out what that number is that's on the inside, you take the middle number, divide it by 2. What's negative 16 divided by 2? Negative 8. Now notice it's negative. And so I got to have the negative in front of it here. Now, I want to check and make sure this is actually right. So, what is negative 8 squared? What does that equal? It equals a positive 64. Which is the last number. That's what I needed it to equal. So yes, this is correct. That one is done. That is the correct answer. All right. Now the one on the right. I again start by looking at every single term and see, can I divide every term by the same thing? So 12x squared, 16, and 64. Can I divide all those by the same thing? Yeah, I can. For one thing, I notice the numbers. The 12, the 16, and the 64. They're all even. So already I know they're at least divisible by 2. It's just a matter of looking to see if there's something bigger. Is there something bigger than 2?
4.
Yeah, 4. And whenever there's something bigger, use it because it's going to make your life a lot easier. If you just take out the 2, you're going to have to take out another 2 later to get to the 4. All right, so I'm going to factor 4 out of both these terms here. When I do that, remember, I still have to write the parentheses there. Now, actually before I do that, I do want to check one other thing. Can I factor out any x's? Well, do I have an x in every single term? No. That's why the answer is no. That's why it's just the 4 that we can pull out. All right, so then we divide out by 4. So that gives me 3x squared. Minus stays a minus. 16 divided by 4 is 4, so that's a 4x. And then 64 divided by 4 is 16. I want to double check myself. Can I divide all three of those by the same thing? Well, I don't see x's in every term, so I can rule that out again. 3, 4, and 16, can I divide all three of those numbers by the same thing? No. And so that is then, yes, my final answer. That one is totally factored.